Assalamualaikum class. Today we are going to take the lab session of lab number 11. The topic of the lab is maximum power transfer theorem. And the title of the lab is to assemble the resistive circuit based on the maximum power transfer theorem and measure the circuit parameters using the software tool. The main objective of our lab is to organize the Thevenin equivalent circuits and display maximum power of the given circuit using software tool. The lab CLOs and the PLOs that we will achieve at the end of the lab are CLO1 and CLO3. So before we're going to start the maximum power transfer theorem, we need to take an overview of the Thevenin and the Norton theorem. You can see in this slide, the Thevenin equivalent circuit is used to simplify the complex circuits, and the Thevenin equivalent circuit consists of a Thevenin equivalent resistance in series with a voltage source. So the main difference between the Thevenin and the Norton is the Norton equivalent circuit consists of a Norton equivalent resistance in parallel with the current source. So this is a basic or a main difference between the Thevenin and the Norton theorem that we have already done in the lab 10. So basically, maximum power transfer theorem is the application of the Thevenin theorem. The amount of the power received by a load is an important parameter in electrical and electronics applications. So in the DC circuits, we can represent the load with a resistor having resistance of the RL ohms, and similarly in the AC circuits, we can represent it with a complex load having an impedance of the ZL ohm. So this is the main difference between the DC circuits and AC circuits in terms of dealing with the maximum power transfer theorem. So the maximum power transfer theorem states that the maximum amount of the power will be dissipated in the load resistance if it is equal in value to the Thevenin or the Norton source resistance of a network supplying the power. So this is the main definition of your maximum power transfer theorem, in which it is very clear that the maximum amount of the power will be dissipated if the value of the resistance is equal to the Thevenin or the Norton source resistance. So here is your in-lab task, and it is the same as we have already done in the lab 10. So let's revise the Thevenin theorem, because to find out the maximum power transfer theorem, we need to construct a Thevenin equivalent circuit. So let's have a revision of the Thevenin theorem. For Thevenin theorem, we need two important parameters. The first one is the R Thevenin and the second one is the V Thevenin. How to calculate the R Thevenin? These are some steps that is given in this slide. The first step is to remove the RL and open the current source, and short circuited the voltage source. So here in this original circuit we have a voltage source, so that's why in the modified circuit we short circuit our source voltage. These are the same steps we have already done in the previous slide. So just we have a revision of the how to apply the Thevenin theorem. So after doing this, you are supposed to calculate the R Thevenin. After calculating the R Thevenin, the second step is to calculate the V Thevenin. For the V Thevenin, the first step is to open the load resistor again, as you can see that in this figure, and then reconnect the current source or the voltage source like this, and then after that you are supposed to be calculate the Thevenin. So these are the main steps to calculate the Thevenin equivalent circuit. Here is your modified Thevenin equivalent circuit, but in this lab We are not going to calculate the voltage or the current across the load resistance. We are going to calculate the maximum power. And for the maximum power theorem, now we set a load resistance. So here is the main difference. You can see that in the last step we have a fixed value of the RL resistor, but in this case we have a variable load resistance. So why we use the variable resistance? Because we adjust our load resistance so that the maximum power can be dissipated. So when the load resistance is equal to the R Thevenin, then our maximum power is dissipated across the load resistance. So these are the main steps to find out the maximum power theorem. Here is the data of your original circuit, and after implementing the given circuit in the PSpice, you're supposed to fill up this results that are based on the Thevenin theorem, in which you can see that your R Thevenin is going to change by a multiplying factor of 0.8, 0.9, 1, 1.1 and 1.2. Uh, so that you can find out different values of your voltage across the point 1 and 2, and then you can easily see when the maximum power will be dissipated across your load resistance. So after completing your table, you can easily find out that the maximum power can be dissipated across the RL when the load resistance is equal to your Thevenin resistance. The evaluation procedure is the same as we have already done in our previous lab. So in case of any question, you can ask easily. Thank you for today's session.